So hard problem today. We have a list of numbers and we want to find if how many steps we can make to jump from repeating numbers from first position to the last position, and we can jump any repeating digit number or jump adjacent numbers like this. So the solution is BFS, breadth first search. You put this first value in a queue, then you group these values to positions. So for value 0, the position is 0, 1, and so on. For value 2, it is 0, 1, 2, 3, 4, 3, 4, and so on. And then you do BFS and jump in each step. You go left, right, and you iterate over this graph by value. This graph is what you put in the hash map. Now the tricky part is how can you optimize it to be faster. So the BFS is not equal to other BFS because you can optimize it. So the first optimization is when you visit this group of the same values, you can or you should remove it from the graph. Do not visit it ever again and not iterate over it, because this group can be entire list of 10 to the power of 5 elements, and if you would do these jumps and then you do iterations again and again, you would make n squared iterations, and this would not be accepted. Now another optimization is, so the first optimization is remove from group, remove from group. It's I. Second optimization is put or mark visited early. So mark visited early. Why is that? Because the same logic. So we don't want to iterate or put in a queue the values you already have put in this queue. Let's look at the code. This is my accepted Kotlin solution. So this is grouping. You have to use mutable map to do the removal, and you have to mark visited earlier. So as soon as you put the value in a queue, you have to mark visited and not put duplicates. That would trim the time and space that your algorithm takes. Now let's look at the shortest variant of the same code. So this is my Kotlin version. Basically the same code, just a little bit shorter. Set off is shorter than list off. This is plus in same collection. I used hash set instead of Boolean array. It is shorter. Now let's look at the Rust code. This one, or maybe this one. So the timing result is not stable. The same code gives me from 7 milliseconds to 22. and you have intergroup by, intergroup map by or B, and it's either those. So one ladder is the same as the Kotlin one, and then infinity loop without its own statement, and then basically this group gives you some flatten chain, basically all the same. The visited is vector. And that's it for today.